This is Mrs. Zappia with Lesson 3 from Module 4, Comparing Quantities with Percent. Student outcomes for this lesson. Students use the context of a word problem to determine which of the two quantities represent the whole. Students understand that the whole is 100% and think of one quantity as a percent of another, using the formula quantity equals percent times whole, to problem solve when given two terms out of three from a quantity, whole, and percent. When comparing two quantities, students compute percent more or percent less using algebraic, numeric, and visual models. It is important for students to understand that the part in a percent problem may be greater than the whole, especially in problems that compare two disjoint or separate quantities. For example, a quantity of dogs versus a quantity of cats. For this reason, the formula part equals percent times whole will be changed to quantity equals percent times whole from this point forward. Pause the video and copy the two essential questions for this lesson. Why did the word part change to quantity in the percent formula? And number 2, how did you decide which quantity in a problem should represent the whole? Before we get started with example 1, let's go over the formula that we're going to be using and where it came from. So here's what we know about percent. We know that the percent means out of 100, but can also be compared to a part over the whole. So we took this equation yesterday, or this relationship, and we manipulated the equation by multiplying both sides of the equation by the whole. On the right side of the equation, the whole divided by the whole cancels it, or equals 1, leaving you with the part. And on the left side, you have the whole times the percent. So we are rewriting our equation. Now it says that the part is equal to the whole times the percent. I'm going to rewrite that as the percent times the whole. And then we know now that the part is not always smaller than the whole, so we're going to change that word, and we're just going to call it the quantity instead. So the quantity is equal to the percent times the whole. You'll want to memorize this equation or formula. In example 1, the members of a club are making friendship bracelets to sell to raise money. Anna and Emily made 54 bracelets over the weekend. They need to produce 300 bracelets by the end of the week. So here's what we know so far. Emily and Anna made 54 bracelets over the weekend. They need to produce 300 bracelets by the end of the week. What percent of the bracelets were they able to produce over the weekend? So we're looking for the percent, and we need to determine what is the quantity and what is the whole. So together they made 54 bracelets out of 300 bracelets. So we are comparing how many they've made to how many they need. What you're comparing it to is the whole. So we have 54 bracelets that are already made. That is our quantity, or our part. How many they need altogether is the whole. So our equation, and it's not a bad idea to get in the habit of writing the words out to help you to memorize the formula. Quantity is equal to percent times whole. And then replace your words with your values. So we know that the quantity is 54 bracelets. The percent is unknown. Let C equal the percent. And the whole is 300 bracelets. So now we have an equation that you can solve. Hopefully you remember how to solve that. It says to multiply. The opposite of multiplying is dividing. So for this equation, you can divide by 300. You could also multiply by the reciprocal of 300. we're going to divide by 300. Remember to do the same operation with the same number on both sides of the equation. 300 divided by itself is 1, leaving you with C. 54 divided by 300 is 0.18. Now remember that the problem says what percent, and this is answering as a decimal. So we want to change our decimal to a percent. Remember when you change a decimal to a percent that you are multiplying by 100. Another way to think of that is you are essentially moving your decimal 2 places to the right. So this becomes 18. So C is equal to 18%. What percent of the bracelets were they able to produce over the weekend? 18%. So let's compare this to what we know about double number lines. So we'll use 2 bars. One of them will represent the percent and one of them will represent the bracelets. On the left we have 0% and on the right we have 100%. And 100% represents the total number of bracelets. The total number of bracelets that they need is 300, so that matches up with the 100%. They've produced 54 bracelets. So 54 bracelets, you want to place that on the number line. It's less than half, let's call it right about there. 54 bracelets. And that is, the question was asking, what percent is that? So we have a proportional relationship comparing 54 to 300, and we want to know what would it be out of 100. So I take my 300 bracelets and I divide that by 100 right here. 300 divided by 100, and that gives me 3. What that means is that 1% represents 3 bracelets. Okay, 100% represents 300 bracelets. So if I divide 300 by 100, that gives me 3. What that means is that 3 bracelets represents 1%. So then I want to know how many 3's are there here between 0 and 54. So then I do 54 divided by 3, and that gives me 18, and that is the 18%. Part B. Anna produced 32 bracelets of the 54 produced by Emily. So we have Anna producing 32, and we don't know how many Emily did yet. Write the number of bracelets that Emily produced as a percent of those that Anna produced. So what we're looking for is the percent. We're not looking for the percent compared to the total. We're not looking at the percent compared to the bracelets made. We're looking to compare the 2 ladies' bracelets. So one of them is the quantity and one of them is the whole. What you're comparing it to is the whole. So we are comparing the number that Emily produced compared to these that Anna produced. So what we are comparing it to is the whole, and that would be Anna. And then the quantity would be Emily. So we need to know how many Anna produced and how many Emily produced. So we will make a double bar diagram or a double number line to understand this problem as well. So we know that we're comparing the amount that Emily produced to the whole amount that Anna produced. So Anna is the whole, and the whole is always the 100%. So Anna produced 32 bracelets. And depending if Emily produced more, she would go to the left, and if she produced less, or if she produced more bracelets, she would go to the right of the bar. If she produced less, she would go to the left of the bar. So we need to know how many she produced. So we know so far that 54 were produced, and of those, 32 were done by Emily. So we can subtract to find how many were done by Anna or Emily, getting their names mixed up. All right, so Anna was 32. Emily is, right about here at 22. Over here is 0%, and this is the percent we are looking for. So the whole is Anna, and Emily is the quantity or the part. So let's use our equation. Quantity is equal to percent times whole. Substitute our quantity, which is Emily. Our percent is unknown. Let C equal the percent Emily produced of Anna's. And then our percent is the unknown C, and the whole is the 32 bracelets produced by Emily. So I want you to notice that we are not comparing it to 300 bracelets, which was the total produced. We're not comparing it to 54, which is the amount that they produced together. We are comparing it to 32, which is the amount Anna produced. So let's go ahead and solve this. Divide by 32. Whatever operation you perform on one side, you have to do the same on the other. When we divide 22 by 32, we get 0.6875. And that is a decimal. And this question is asking what percent. So we want to change the representation of this to a percent. Remember, when you change a decimal to a percent, you are multiplying by 100. And when you multiply by 100, the shortcut is to move your decimal 2 places to the right. And so our percent is 68.75. So here's what we know. Emily produced 68.75% of the amount Anna produced. And we can relate that to the bar over here. We can take 32, divide it by 100, and that will tell us the amount that 1% is worth. So 32 divided by 100 is just 0.32. That means that 1% is equal to 0.32. And then we can do 22 divided by 0.32 to find out what the answer is. And that gives us the 68.75%. Right. So part C, write the number of bracelets that Anna produced as a percent of those that Emily produced. This sounds very similar to the problem that we've just done. So let's read it carefully. Write the number of bracelets that Anna produced as a percent of those that Emily produced. So we're still looking for a percent, but instead of comparing Emily's to Anna's, we're comparing Anna's to Emily's. So we're comparing those to Emily's, and when you're comparing it to Emily, that means that she is the whole. So on our double number line with the 0 and the 100, the 100% represents the total, and the total is what you're comparing it to. And we are comparing it to Emily this time. And we know that Emily created 22 of the bracelets. And then Anna produced 32 of them. So where do you think 32 should go on this number line? Would it go to the left or would it go to the right? Since it's more than 22, it will need to go to the right. So I'm just going to need to move Emily's name down there a little bit. And I'm going to need to make that bar a bit longer. So 100% right here, and then 32 will be over here, and this is Anna. So notice that 22 is still to the left of 32 because it's closer to 0. And 32 is more, so it's on the right. But notice where the 100% is compared to where it was before. 100% represents the total. And in this case, Emily is the total or the whole because we're comparing it to her. So what we would do to solve this problem, can you think of how you would solve that problem? Well, let's go back to the equation. The equation is quantity equals percent times whole. And we know that our quantity is Anna and our whole is Emily because we are comparing it to Emily, and what you compare it to is the whole. So percent will let C equal the percent of Emily's compared to Anna's. So our quantity is 32. That's right over here. And our percent is unknown. And our whole is 22. To solve our equation, divide by the coefficient. Divide by 22. A number divided by itself is 1, leaving us with C. 32 divided by 22 equals 1.45 repeating. And remember that this is a decimal representation and we are to write it as a percent. So when you change a decimal to a percent, you multiply by 100 and move your decimal 2 places to the right. So that's going to equal 145.45 repeating percent. And this is an unfamiliar percent. We are not generally used to working with over 100%. So understand that the reason it's more than 100% is because Emily produced less than Anna. Anna produced more, so if it was equal, it would be 100%. But since she produced more, it's over 100%. All right, let's go down to exercise 1. There are 750 students in the 7th grade class and 625 students in the 8th grade class at Kent Middle School. What percent is the 7th grade class of the 8th grade class at Kent Middle School? So we know that we're talking about quantity, whole, and percent. And this is a percent problem that can be solved using that formula, that quantity is equal to percent times whole. I know that I can use this formula because I'm looking for a percent and I have a quantity and a whole, or a part and a whole. The part and the whole are the 7th graders and the 8th graders. So we want to know what percent is the 7th grade out of the 8th grade. So the 7th grade is the quantity, or the part, and the 8th grade is the whole, because we are comparing it to the 8th grade. Since we are comparing to the 8th grade, it is the whole. So we have 750 that are 7th graders. And we have 625 who are 8th graders. So it helps to identify what is your whole, what is your quantity, and what are the numbers. So our quantity is 750, our whole is 825. Another way to do this so that you don't make a mistake is to write the words. So we said that our quantity is our 7th graders and our whole is our 8th graders. And the 7th graders is 750 students. Let C equal the percent times the whole 8th graders, which is 625. So stop and think for a minute. Do you think this is going to be more than 100% or less than 100%? All right, let's find out. This says to multiply, so we do the opposite. you can either divide by 625 or you could multiply by the reciprocal 1 over 625. So our percent, it turns out, is more than 100%. So we do 750 divided by 625 and we get 1.2. Remember that this is a decimal representation and we are supposed to write a percent. To change a decimal to a percent, multiply by 100 or move your decimal 2 places to the right. So the answer is 120%. So what this means is that the 7th grade is 120% of the 8th grade. If it was the same, it would be 100%. If it was smaller, it would be less than 100%. Since there are more students, it is more than 100%. The principal will have to increase the number of 8th grade teachers next year if the 7th grade enrollment exceeds 110% of the current 8th grade enrollment. Will she need to increase the number of teachers? Explain your reasoning. The question is asking, what percent more are 7th graders compared to the 8th graders? So we know that there are 20% more. If it was the same, it would be 100%. So there are 20% more. So it says they could exceed 110%. Well, that means it could exceed it by 10%. So the answer is yes, definitely. Will she need to increase the number of teachers? If it exceeds 110%, well, it is 120%, so it is larger, so they will need to increase the number of teachers. At Kent Middle School, there are 104 students in the band and 80% or 80 students in the choir. What percent of the number of students in the choir is the number of students in the band? So again, we want to determine what is the quantity and what is the whole. Remember that the whole is what it is being compared to. There are 104 students in the band, 80 students in the choir. It doesn't matter which one has the larger quantity. That does not help you determine the part and the whole. What percent of the choir is in the band? What percent of the choir is the band? So we want to know what is our whole and what is our quantity. Well, what are we comparing it to? We're comparing the number of students in the band to the number of students in the choir. What percent of the choir is the band? So our choir is the whole. Whoops, I wanted to write whole there. And the band is the part or the quantity. And we know that the choir, there are 80 students, and the band, there are 104 students. So our quantity is 104 and our whole is 80. So our equation is quantity equals percent times whole. Our quantity is 104. Our percent is unknown. Let C equal the percent times the whole, which is 80. Divide by 80, divide by 80, and 104 divided by 80 is 1.3. So that is the decimal representation, and remember that we are to represent our answer as a percent. To change a decimal to a percent, multiply by 100, essentially moving your decimal 2 places to the right, and so the answer is 130%. So the question was asking what percent of the students in the choir is the number of students in the band. And since there are more students in the band, it is 130%. At Kent Middle School, breakfast cost $1.25 and lunch cost $3.75. What percent of the cost of lunch is the cost of breakfast? So we want to know again what percent. So we will need to determine what is the quantity and what is the whole. So the question is asking what percent of the cost of lunch is the cost of breakfast? What percent is lunch compared to breakfast? What percent of lunch is breakfast? So what we are comparing it to is breakfast. Or actually, what percent of lunch is breakfast? So we are comparing the cost of breakfast to lunch. No, this is tricky. What percent of lunch is breakfast? So our lunch is our whole and our breakfast is our part or our quantity. Notice that I didn't even look at the prices to determine part and whole. All right, so we have breakfast costing $1.25, so I'm going to write the $1.25 by the quantity, and the lunch is $3.75, and that is my whole. Let C equal the percent. Our formula is quantity equals percent times whole. Our quantity is $1.25. Our percent is unknown. Our whole is $3.75. Divide by $3.75. And $1.25 divided by $3.75 is equal to 0.33 repeating. Remember that we are to answer this as a percent. So we want to change the decimal representation to a percent. To change your decimal to a percent, multiply by 100, essentially moving your decimal 2 places to the right. And so our answer is 33.3 repeating percent. So the question was asking, what percent of lunch is breakfast? Breakfast is 33.33% of the cost of lunch. And what I did there is I changed the 0.3 repeating to 1/3. And does that make sense? Breakfast is $1.25, lunch is $3.75. Breakfast is 1/3 of the cost of lunch. Yes. And 1/3 is the 33.33%. All right, so let's go down to our summary. In this lesson, you have learned visual models or arithmetic models can be used to solve problems that compare quantities with percents. Equations can be used to solve percent problems using the basic equation, quantity equals percent times whole. Quantity is the new percent formula, is the equivalent of part in the original percent formula. And again, the reason that we changed the word part to quantity is because part implies that it is smaller than the whole, and our quantity is not always smaller than the whole.